Hello, this is Aniket, and I applied for AROGO AI ML engineer internship role. And currently, I am in my final semester. I am pursuing bachelor's degree in with specialization in machine learning from Vellore Institute of Technology. I would be recording demo video for AROGO AI task submission. So for the structure of video, I would be first explaining the data sets, what and how I propose the solution, and how I am going to predict the possibilities, and then we would be moving on to methodologies and implementation. So for the task, we were given to develop a self-analysis mental health model, and for dataset, we were given liberty to choose any of our choice. I decided to go with the second one, depression and anxiety symptoms. So if I show you the dataset, we are having two types of columns. One column is of scores, one type of column like of BMI, of GAD score, of PHQ score, and EP worth score. Other, I would be considering them as features, binary or categorical features, that is either present in 0, 1 or in some few numeric labels like mild, moderate, severe, basically encodable into few categories ranging in single digit. So if I move on to the structure of the program that I shared through my GitHub, I am having few sections like this is the section of data pre-processing. I am doing all the pre-processing stuff in this Jupyter notebook. The second section is of model development, which is in this file. And the third section is of LLM experimentation, which is in the third file. And finally, the UI is present in the UI.py. And I'm using Streamlit for all the UI purposes. And my models are saved in this PKL file, scalar.pkl, and PTH file, mental health model. So coming on to data preparation step, I was doing some data cleaning on for the EAD. If I plotted the density graphs for the scores, and except BMI, which was average around the mean, the PHQ GAD and EP per score had a similar kind of plot. So what I could recognize with that was that I would be having a lot of overfitting problem. So what I considered in the entire duration of this project was that even if I am getting a label as moderate, I would be considering it as a probability of mental health disease, so that we could have few categories of data that would be coming positive. Because if you see the original data, all the symptoms like depressiveness, suicidal, depression, anxiety severity, they are very mild and giving false values. So if we are considering all these data, it would be very difficult to predict a single mental health model. And every time if the answer is coming as false, then it would cause some overfitting problem. So yeah, that was my interpretation from data analysis. And further on, I get with the feature engineering with the same logic. So in feature engineering, what I did was I made around 12 to 15 different types of mental health conditions like depression spectrum, anxiety spectrum, sleep related conditions, and suicidal and self harm risk spectrum. These are around 12, and what I did was I categorized them based on their symptoms, and these were binary encoded. I made them through the logic I have written. I considered 2 3 symptoms for each kind of condition, and I applied logic for each of them. So this was with feature engineering. So we would be predicting all these 15 kinds of mental health conditions in the future, like model development. We would be training these. So if we move on to model development, what I did was I loaded the final mental health data set, and what this was we were getting from the previous step in data preparation. This is basically our original data set combined with the predictions for the conditions that we already had. All this part is after sleeplessness, all this part is generated from the feature engineering step that we did. So I loaded this model, and for model I decided to go with linear regression and neural networks. Linear regression I take because as I get to know that we are only having 783 columns of data, so it was a very small data. And as this model is already prone to overfitting, I decided to choose linear regression. Earlier I was taking random forest, and I also had trying XGBoost, but I decided to go with neural networks as because in feature engineering I had a sense that the complexity of the data would increase if we consider more symptoms for a single mental health disease. So I decided to go with neural networks because what originally would have happened that linear regression accuracies and scores are far more better than that of neural networks. So if I had taken a challenge to match the scores of neural networks to the linear regression model, which was I achieved good in fine tuning the model. So yeah, we were given a task of making a multi-class classification model for the all the mental health condition around, they were 12 to 15 in count. We had to predict a 0 or 1 based on what the conditions we are getting from the model and the input data. So yeah, if I move on to below, we are calculating accuracy, precision, recall, F1 and ROC accuracy scores for each of both the models, and we are training the data on them. And if we have a look at the results like logistic regression accuracy and neural network accuracy, all the accuracies in neural networks are little bit less than that of logistic regression. So what I previously intended, I was able to achieve that to a great extent. Then finally, I decided to save the files. So I saved them in PKL and PTH file for both the models, and thereon we were decided. I decided to take Lime for interpreting the model prediction. So in Lime, what happens is that we are given test instances. Actually, we select them, and for example, in X train, X test, I am taking a sample index of 0 instance. So what we do here is we create variations of this data, and we study how they affect on model's output, and we observe them. So all the logic is written here. Then we get a linear regression approximation to approximate a local boundary around the test, and this allows us to judge which feature judge the model classification. So all this judgment is stored in these HTML files. So if I try to open any one of them, mm, yeah. So on the left top we have the prediction probabilities, which are of various conditions being present in the prediction. In the middle part we have feature importances, like if we consider chronic and not chronic stress, all the features which are present in the yes part are more relevant features, and in the not chronic stress part, these are the less relevant features. And if we have a look at the right bottom, these are the actual feature values for the instance here. So this was with the model development. Then I decided to move on with the LLM experimentation. So for LLM experimentation, we were given it as an optional section. We had to provide natural language explanations and coping mechanism, something like that. I decided not to go with prompt engineering. I was using a T5 model transformer. So if I move on to that part, yeah, here I'm basically loading the model and from the PTH files, and I'm hard coding the input data here. ठीक, so it consists of two parts. One is the mental health, two classes. One is mental health assistant class, and another one is the safety protocols. So if I show you, this is the mental health knowledge. This is the knowledge base we are having for. I made custom made, like I custom made the feature engineering part. It consists of condition. Each of the 15 conditions, its symptoms, its explanation, and coping mechanisms and actions for each, like MDD, dementia, SAD. Yeah, and this is the predictions that we were getting. So for the predictions, we were getting it from different probabilities listed here, and we are either getting a 0 or a 1. So if I move on to the classes I was talking about, we have two classes. One is the mental health assistant class present here. This basically consists our T5 transformer model, and how I downloaded this model. This model is present in the mental health T5 folder. I downloaded this in the directory, and the download build script I have marked it in the README file of the submission repo. So one could get it from there, and it has thresholds for all the predictions and logic that if thresholds is crossed, then prediction is counted as a yes. We are generating insights with probability. We are generating severity of the classification. We are determining urgency, and we are also generating reports using this class. And for safety protocols, we have some crisis resources, string format. We have emergency prediction, and we have some emergency protocols, that is some natural language logic that I had made. So yeah, in this part, I am basically making the report available in the PDF file in the same directory, which is saved here, mental health report. Yeah. So if I show you the mental health report, it is like this. So all the 15 types of mental health diseases that I'm describing, all their reports and their clinical insights are listed in this using natural language. So for a condition like burnout, we are giving it severity, clinical insight, probability, urgency, symptoms, explanation, coping mechanism, actions, and etc. So at here our LLM experimentation work stops, and we move on to the last part, that is UI. And for UI, I am considering Streamlit. So all the Streamlit running scripts I have given in the README file. So one could start the script from there. I would refresh this. So for the UI, user could input the data, and earlier I was explaining that it was difficult for this course because this course had a range between like 0 to 25 to 0 to 21, and the original data set that we were having, the scores were only listed at low frequencies, collapsing at max 15. So there is some pre-processing that needs to be done at the UI, and that logic I have written in the UI.py file. So this consists that logic. So through that logic, what we were doing is that we are taking input from the user, and then we are ingesting it to the model, like in the encoded format, etc. So if I take little values, BMI is little less, 22.5. Yeah, 22. Okay. So if I ingest my data into the mental health model, first it would get converted and then it would get ingest. So if I click analyze mental health model, it would generate a similar report that we were given in the PDF file. So yeah, a similar report s- with probabilities and other clinical insights. Yeah. So the README file consists of all the build scripts and all the interference script. I hope I was able to explain all the demos in a good manner. Thank you.